Hi folks, my name is Bapiraju Nanduri, and in the Lessons from the Field series, we'll look at testing in DevOps, strategies, tools, and some of the best practices. I've put together this presentation along with my colleague, Mr. Raghu, for the World Conference Next Generation Testing that was held in Bengaluru in July 2019. We'll cover this in three sections. We'll look at some basic concepts of DevOps. We'll try to demystify DevOps. Then we'll delve deeper into understanding what is continuous testing and what are basic tenets of continuous testing, and then where it stands in the overall context of DevOps. And also we'll look at a case study. Given it's a Lessons from the Field series, we'll look at an enterprise product development, a scenario, and look at different phases before and after effects of implementing DevOps. Let's jump right into demystifying DevOps. This is one of my favorite definitions of DevOps from my favorite author, Jez Humble. DevOps is not a goal, but it's a never-ending process of continual improvement. So we're not talking about DevOps in the context of process compliance, or we're not talking about DevOps as a box to be ticked in the overall process compliance. We are talking about DevOps as a process where there is feedback loop, and you're learning from the feedback, and you're taking the feedback to improve further in your next cycle, and it's an iterative process, and that process is never ending. So you have built something and you have learned from the feedback some improvement areas, and you have incorporated that feedback into building something better. So that's overall continual improvement process. This is the pipeline of DevOps, the famous pipeline of the DevOps. So you see Dev on the left and Ops on the right. There are different phases in Dev and Ops sections, phases of your development. So you start with plan, then you code, you test and build, and they are the phases of development. And then you switch to Ops, where you release, you monitor, and you respond to the feedback and learn from the overall process. And it doesn't stop there. That feedback and lessons that are learned are incorporated into the plan of the next phase of development. Then you code, you test, build, and then you release, you monitor, and you learn. And the next phase of development again, plan, code, test, and build, release, monitor, respond, and learn. You get the picture. Now, this is one of the most important aspects of DevOps. I mean, this gives you the bird's eye view of the overall pipeline of the DevOps with all its phases. It is interesting to see there are a lot of tools and techniques that are available for you to take control over each of these phases. We'll look at each of them in detail in the coming slides. While this picture looks very busy, it actually reflects the race to own the pipeline. You see tons of tools and several product development companies which are trying to own each of the phases of the DevOps pipeline. Let's, for example, look at the planning phase. There are tools from Google Drive to Office to Google Docs to Box to Dropbox to Slack. There are several tools that provide various methods to support your planning phase. And let's look at the build phase. Now, there are tools ranging from GitHub to the Git to the JFrog to Docker containers to the Kubernetes to whatnot. There are several technologies and tools that are available to help you in the build phase. Now, in the continuous integration phase, you got Jenkins, TeamCity, Travis, and very popular tools like that will help you to deal with your continuous integration. Now in the deploy phase, you got support from tools like Chef, Puppet, Amazon. There's Ops Genie, and so on and so forth. In the operate phase, you got several popular tools like from App Dynamics, Splunk, Sentry, Rollbar, Raygun, New Relic, Nagios. There's several tools that help you in the operate cycle. And in the continuous feedback, you got tools from Salesforce, and you got tools such as Zendesk, Cucumber, BrowseStack, and providers like ServiceNow and so on and so forth. So it's a busy chart as we started looking at it. You see each of these phases is supported by a lot of tools, and some of these are proprietary tools, and then some of these are open source. So that you have a lot of support for each of the phases of the DevOps pipeline. In fact, this chart gives you a lot of permutations and combinations and several options that will help you to customize, pick and choose the tools that meet your business requirements, your development lifecycle, and your release process. That's the flexibility that all of us have today. We have seen the DevOps pipeline. Now let's look at some of the DevOps principles. Again, going back to Jez Humble, my favorite author, and then the author who has actually come up with a lot of these principles in his book on the DevOps. He beautifully described the principles of DevOps in this acronym, CALMS. We'll talk about culture, automation, the lean methods, measurement, and sharing. These are the 5 principles that we will look at in the context of DevOps. First and foremost, culture. So there is a need for mind shift here. So the technology is to be seen as an enabler rather than the end goal, meaning technology should be able to serve the business needs, and it's not the other way around. So we are not implementing DevOps for the sake of implementing DevOps. We are not implementing DevOps because it is the nicest and the coolest thing to do. We are implementing DevOps because it's a technology, it's a process improvement that actually serves the business need. And that's a mindset shift. The implementation of DevOps has to be backed by the business executives. Now, the overall process improvement is going to result in significant savings, especially the cost savings for the business. Not only that, it helps folks to get to the market fast. Because of the continuous feedback mechanism, it also improves the overall product and improves the overall experience for the customers. So the implementation of the DevOps must be backed by the business executives. It is a common goal between the development and the operations folks. It actually forces these teams to move out of their comfort zone. And there used to be days where the development and the ops teams were working in 2 different silos, and there were dev versus ops arguments flying all around the organization. Now the culture has to shift to a paradigm where the dev and ops teams work together, and they take advantage of the agile methods. You define things, you build things, and then you release, and then you take feedback, and then you implement. Make sure that you're following the agile principles to make your overall development process better and lightweight. That's the culture shift that is required in implementing DevOps. And it is one of the fundamental principles of DevOps. The second principle of DevOps is automation. And my mantra for automation is this: everything that can be automated must be automated. Why? Because automation is more efficient. Yes, there is value in manual interventions, but if we are able to minimize the manual interventions in the overall development process, the systems just become more reliable and more efficient. There has to be a feedback loop to improve the scripts. So you run your automation and you get the results, and then obviously there are going to be areas that your automation scripts let you know. The results are going to let you know where there is a need to improve your automation scripts, and then you put that into the feedback loop. So you take that feedback and then you improve your scripts and then run the automation. This actually gives you a robust build process because of this automation, you would be able to regress your overall builds several times, and manually doing this would be very, very expensive. I would say prohibitively expensive, especially in the context of enterprise development, where you have several permutations and combinations of systems to be tested. So you take advantage of the continuous integration and continuous deployment, and that's key to your automation. Again, there is no manual interventions there. Somebody writes a piece of code and then they check in, then it's automatically integrated. It's continuously integrated with the rest of the development team's code, and also it runs a certain set of tests, and then your automation kicks in, and then you continuously able to deploy the code that is built. And you use infrastructure as a code, and you ensure that your development process has implemented the best practices of the continuous integration and the deployment. So you are able to take advantage of the concept of infrastructure as code. The third DevOps principle is lean development. So there is constant flow of small and easier to control changes. Yes, you'll have to build that big feature, but is it possible to split that feature into smaller chunks and easier to control chunks that you can actually deliver, that your developers can deliver one after the other? This lets you to make sure that the work that is in progress is always limited. You do not have large chunks of work that is in progress. You have limited work in progress, and you're able to focus more on value and not quantity. For example, you are able to deliver a sprint, a development sprint, and let us say majority of the deliverables of that sprint are not testable or not even usable by your customer. Then that sprint is practically unusable. Those deliverables are unusable. Let's contrast that with a situation where you got a sprint where you're able to deliver small and easier to control changes, and you're able to test them end to end. And not only that, your customers are able to use those features and see the feature development, even though they are small from end to end. Now, that is value of your sprint. So if you shift your focus of your development sprints from quantity to value, then you have achieved the objectives of the lean development. Always ensure that your work in progress is all limited, and then you're able to deliver more value. So the 5 principles of lean software development: value, eliminate waste, then you produce more value. Then value stream for the entire life cycle. You make sure that there are no interruptions in the flow, and just-in-time development. You pull whatever is required so that you eliminate waste, as well as you ensure that there is limited work in progress. And you aim for perfection and you're continuously looking for improvements in the overall process, taking feedback and then improving your overall process. That's lean development. The fourth principle of DevOps is measurement. In the development life cycle where you have plan, do, check, and then act or adjust, metrics plays a key role. There are organizations which measure everything from the traditional systems background and use the metrics that they have gathered for acting or adjusting their plans. Now, the, the plans evolve over a period of time. They're improved over a period of time, and then the overall process will evolve based on the feedback loop. Now, what over the last several years, what we have observed is measuring everything may not be the right thing to do. Measuring what matters is what really gives you the return on investment. The metrics require significant effort, and then you'll have to identify the tools, and then you'll have to identify people who run these sports, and then analyze things, and then come back to you with conclusions so that you can actually take specific actions for your and include them in your next cycle of development. So measurement comes with a cost. So measure what matters is really the mantra. It all depends on your development context. For some of you, it is the lead time for changes. If I bring in a change today, when would you be able to turn it around and then deliver back to me? What's the lead time for change? And for some, it's deployment frequency. How frequently can you give me a new builds and new releases, and which means taking your new features to the market. And for some of you, time to restore service. And then if my service goes down, what is the SLA, and what is the time that you need minimum to bring back up the service and things like that. So the metrics depend on your business context, but then it is very, very important for you to define those metrics that matter to your and contribute to your overall product development lifecycle improvement. The fifth and the last principle of the DevOps is sharing. And this is where I have seen a lot of individuals as well as organizations struggle. Many people try to do things from the scratch. They have a business problem to solve, and they try to reinvent the wheel in the sense of pretty much doing everything from scratch, whether it is process improvements or whether it is product development. Now, one of the main principles of the DevOps is to share the best practices and also share the things that did not work for you. Whether your experience is a successful one or not, your experience is an experience that matters a lot to others, and then that can benefit everyone else in the community, and you're better off sharing that experience with others in the same way that you would like to learn from others' experience as well, so that you can actually save a lot of time and money in your process improvement cycle. This is done in the context of the open culture. We have looked at the culture as one of the first principles of DevOps and the mind shift that is required to shift to an open culture. In the spirit of open culture, sharing is very, very valuable. Sharing all our experiences, and then sharing the best practices, and sharing things that we should do and should not do, and things that worked and did not work is a very valuable practice. And then that is done in the spirit of collaboration, and that improves the overall efficiency of the DevOps teams across the community. So there you go. We looked at the DevOps principles at a high level, the CALMs, culture, automation, lean methods, measurement, and sharing. We looked at each of these things at a high level and then tried to understand why each of these principles make a lot of sense in the context of DevOps. Now, with that, we conclude the first section, DevOps principles. Now, let's take a closer look at continuous testing in the context of DevOps. Let's spend some time trying to understand the reference architecture of DevOps. We looked at the pipeline at the beginning of our session. So this is another depiction of that pipeline here. So we'll start with business planning, and then we get into the development and test cycle, and then the next phase is the release and deployment, and then we continuously monitor, we take the feedback for optimization, and then we incorporate that into the business planning, and the cycle continues. So there are 4 phases here, as you can clearly see on the DevOps continuous feedback cycle. You steer, then develop and test, deploy, operate, and incorporate that feedback into your steer phase and continue the loop. There are standards, best practices, and ecosystem working as the framework for your entire DevOps reference architecture. So from this picture, we will spend the next couple of minutes, we'll spend some focused time on continuous testing. There are several key practices that help you with continuous test. A couple of those things I have mentioned here: test management, test automation, analytics, defect management, and setting up the test infrastructure. So in the test management, we are talking about the overall scope of the test that need to be performed on the function that is being delivered. Whether the functional verification tests are enough, or we also need to include the scale and system verification tests, whether accessibility tests are required, or whether you need to do globalization testing as well for the function to be delivered, whether you need stress, load, all kinds of testing that is required to ensure that your function that you're delivering and the feature that you're delivering meets the customer's requirements. All those tests, the scope of those tests, and then how you're going to perform those tests, and the details of those test cases, that all forms part of test management. Now, test automation is where you automate the manual test cases that you have written. And these are the scripts that run. You could be running these things on nightly builds, on weekly builds, or the daily builds. The manual interventions are minimalized, as we have seen in the DevOps principles. One of the key principles of DevOps is automation, and the test is a perfect place to ensure that you have automated to the maximum extent possible, so that your testers can actually focus on more non-redundant and non-repetitive tasks. And that's exactly where there's a lot of value that comes out of manual testing in corner case scenarios and in creative testing. That's where the testers would be able to bring in a lot of value. Now, the test analytics, there are a lot of documents or reports that are produced from your test's execution. And you need to have a system in place to analyze all those reports and then give you feedback on what's working, what's not working. So defining test analytics and the metrics that you would like to measure is an important best practice in the continuous test environment. Defect management is another important aspect with the specific SLAs and the turnaround times and the severity of the defects and the priority of the defects. Who's going to raise the defects? Are your automation scripts capable of raising the defects when they find those things, or is manual intervention required? What happens to the defects after they're raised, and then how are they addressed, and how are they fixed by the development team, and what happens when the development team does not agree that the defect is a functional defect, and how do we resolve such conflicts? And also, when the development team fixes a certain defect, then how are you going to verify that, and in what timelines, and what are your acceptable number of defects in a sprint, in a release, and so on and so forth. So defect management, again, is one of the key practices to ensure your continuous testing is successful. Then last but not the least, a test infrastructure. Now, your enterprise product may require a certain type of machines to be set up to be able to run all the automation and manual tests that you have, whether these are functional verification tests or system verification tests or accessibility tests or globalization tests or all kinds of tests. You would require a particular type of setup that is needed for your tests to run. And if you have your nightly builds, or if you have your regression tests that are running on a nightly basis or on a daily basis or on a particular frequency, then you would require a setup of these infrastructure as well to support running those tests. So having test infrastructure in place to support your development model is extremely critical for the success of continuous tests. What are certain things that you need to take care when adopting continuous test process? Here are some guidelines. Objectives and scope. Remember, it is a cultural transformation. Everyone contributes to software quality. It's not the responsibility of the test teams alone. That the quality is also the responsibility of the developers, the ID people, the release folks, the operations folks. Everyone contributes to software quality, and it's the responsibility. It's a collective responsibility of the development teams. Now, you should embrace the test automation, and that's again a paradigm shift in thinking. Automation should be prioritized, and then it should be allocated resources. Organization should start investing in the tools and techniques of automation, and at times it may also be required that you need to train your resources for test automation. Make sure that there are no delays in test environment provisioning. That's again one of the major frustration reasons for test engineers, where they're ready with all the tests to run, but they do not have a test environment, or the test infrastructure is not set up appropriately or not set up in time for them to run the tests. Another thing is, do you see system or performance issues late in the cycle? And then always when issues are seen late in the cycle, it's very hard to fix them. The cost always is much more when fixing defects much later in the cycle. So is it possible to left shift some of those cycles? Something that you will have to think through. Then, do you see many defects due to requirements mismatch? Are your developers and testers on the same page when it comes to understanding the requirements? Do you involve your testers early in the process such that they are able to understand the requirements, just like how developers understand the requirements, and then are they able to write and design their test cases and the test cycle according to those requirements. And then how about regression tests every build? Do you do it once every build or once every day, or what's the frequency of your regression tests? Remember, running those regression automated suites will give you ability to identify defects earlier in the cycle, especially the defects that are caused because a recent development of the code has broken code that was already written or a function that was already written, right? So defining objectives and scope for your test automation and test process is going to be very important for the success of continuous test development. Now, let's look at the other questions, right? On the maturity levels, is your scope of testing manual or is it possible to automate it? Do you have enough skills to participate in automation? Do your testers have enough skills to participate in the automation? Can they write automation scripts? Do they understand the scope of automation and to what extent that they can automate? And also realize that automation also has limitations, and then beyond a certain limit your automation may not be able to give you a return on investment. So do you understand the scope of the test automation, and do you have the skills required to participate in the automation, and how do you define the return on investment for your automation, and what are the metrics that you use to do those things, right? Then risk mitigation. Are you executing the right set of tests? If you are finding a lot of defects in your late cycles, does the left shift help in getting early feedback? And does your process allow you to left shift some of the features that you're developing so that you can find those issues early? How about your dependent software? How about third-party interface issues? How about uncovering issues that are not in your control, and they're resulting from someone else code or dependent components that code, and that could be open source, that could be other proprietary software, or that could be some other organization within your own company. And how do you deal with such risks, and then how do you mitigate? What is your mitigation plan for such risks, right? So in terms of the process, the test-driven development and the behavior-driven development are some of the best practices that have proved very useful for adopting continuous test processes. Let's look at some of the best practices. As we talked about, quality is the responsibility of the entire team. It's not test team's responsibility. It's not only the development team's responsibility. It's not the coders or programmers' responsibility, but it is the entire team's responsibility. So there is collaborative development spirit, and then the spirit of accountability along with authority. So the people own up the quality as a team's responsibility. Then the goal of automation is not to reduce the headcount. This is very interesting because we have heard a lot of times management investing into automation justifying the return on investment as savings in headcount. The goal of automation must be to ensure you're getting better quality software out, and you're able to go to the market faster. You're able to run your regression suite much more frequently, and then much more longer, and you're able to run them as many times as you want, and you're able to focus your testers' time, your manual testers' time, on areas that you hadn't got an opportunity in the past to uncover defects. These could be the corner cases, this could be the creative testing, this could be ad hoc testing, and so on and so forth, where automation testing, the scripts don't cover the scope of such tests. So that should be the goal of your automation and not mere reduction of headcount. Now, continuous testing is not only meant for testers. That's another interesting thing. So, yeah, of course, testers are the ones who test on a regular basis, and that's their job. But how about developers also participating in testing? How about developers ensuring that the code that they write does not break things that are already there, it doesn't result in regression defects, and also it meets certain quality criteria, and this could be done through unit tests or test-driven development, or many methods are available in the DevOps process these days. How about continuous testing being a practice across the development teams and not just meant for the test teams? Then another best practice that we've observed is that the continuous testing must be integrated into the DevOps pipeline. Now, unless the testing is integrated into your DevOps pipeline, your continuous deployment or your continuous builds or your continuous releases or so on and so forth, none of those are going to work. You must have your continuous testing in the DevOps pipeline. Let's now look at some of the best practices in continuous test automation. A couple of things that we've mentioned here: setup, execution, analyzing, and feedback. So in the setup, your hardware setup and the provisioning using the latest levels of all underlying software, that must be automated. And not only the setup, but also cleanup. When you run your set of tests and then you want to give up the environment for running another suite of tests, your environment should be cleaned up, and then you should also have automated the hardware cleanup scripts as well. Then in terms of execution, you should have test scripts that are able to run unattended end to end, whether they are FVT or SVT regression tests. You should be able to run those things without any manual intervention end to end. You should have an automation to that level. And then you should have automatic installation of the latest build verification past builds. So you should have a certain suite of tests that run on your builds whenever the builds are out, and ensure that and certify that the builds are of good quality, and then that process should be automated. Then you should have log collections across multiple components automated, and you don't need to be worrying about going yourself there and then trying to fetch the logs for each of your tests and automated scripts and things like that. You should have those log collections automated across the multiple components of your product. And also you should be able to design informative reports which help the test team to open defects with all required information. So your logs, when you're collecting those logs, you should be able to gather all the information that is required for your testers to open those defects. And most importantly, again, this is the underlying principle of all DevOps and as well as agile test processes. Feedback is extremely important, as early as possible and as continuous as possible. That feedback is important, and then you take that feedback and then feed it to your future sets of improvements in process. So that's how you take care of the continuous test automation. Since this session is from the Lessons from the Field series, we have included a case study for you to go through. So this case study is about an enterprise product where we take you through the before and after phases of DevOps implementation. So let's look at an enterprise product before the DevOps CT implementation. You understand what CT is, right? It's a continuous testing implementation. And this was a manual process. So a developer works on a particular feature and checks in the code, and the code is checked into the trunk build. Then the QA team runs the functional scripts and they run the BVT on the trunk build, the build verification tests on the trunk build. And then the build is verified and the QA team runs their functional scripts on that build. And then after that, the QA team starts executing their manual tests. And what's the process of that? They request the lab for setting up their infrastructure. Then once their requests are all processed and approved, they set up the lab. Then they manually run the automation bucket. Then they analyze the report, then discuss issues with the development teams, and then raise the defects. Now, what are the constraints in this manual process? Now, each of the test team members was required to identify which is the latest BVT past trunk build and then download and install it. It was their responsibility to clean up and prepare the setup, install the latest versions of all dependent components. And running the test bucket was also an individual responsibility. So as you could see, there is a lot of manual intervention in this whole process. As a result, testers are focused more on the process of setting up the lab and running those things and cleaning up the things rather than actual tests themselves. Now let's look at what happened after the same team has implemented a DevOps continuous test process. So let's look at what has changed after the same team has implemented DevOps continuous testing. Now the developer checks in the code into the code repo, and the build verification tests run on that trunk, and the latest BVT past build is picked up, and there are a set of tasks that are run to set up the infrastructure. The various machines are all set up, and then the environment is all cleaned up, and then the refresh of all latest components and then the interface components and the latest levels is all done. Then the product is installed. Then you got your automated functional test buckets run on this BVT past build. Then the automation actually generates and sends the execution report, and the testers look at this report and then raise the defects. Now, if you look at this process, you got significant benefits like return on investment. Your functional test is automated, and then your regression is automated, and then your systems test is optimized and automated because of not having, or rather removing, the manual interventions from the entire process. You're able to optimize your developers and testers' time, and you're able to actually allocate your testers to spend more time on creative testing and identifying those issues that are not caught by the automation tests. And that feedback is used to improve the automation test scripts in the next cycle, and the continuous improvement process continues. As you can see from the continuous test workflow, there are all these Jenkins jobs which are installing, upgrading, setting up, configuring your systems, and then executing your test buckets. then you're able to run all kinds of these regression runs, functional tests, and verification, the systems tests, and you're able to run them frequently so that you're able to maximize your return on your investment. Since it is an agile and a lean development process, you're able to minimize the work that is in progress, and then you're able to get your features fast to market. Now let's look at a sample test report. So this is a automation test execution report of a Jenkins job. So it's telling us that it's got over 1,000 tests, and then it's able to pass 806 tests, which is 79%, and it has found 30 tests failed, that is roughly 3%, and there are 122 errors, which is roughly 12%. It has skipped about 6% of the tests, and how much time it has taken, when it was run, and so on and so forth. It gives you a comprehensive view of your tests that are run, and then the issues that you have in each of the components here. We come to the end of this session with that. Let's quickly recap what we have learned in this session. We started with demystifying DevOps. We looked at the basic concepts of DevOps and some principles that govern DevOps, the CALMS principles. And then we looked at continuous testing from close quarters. We looked at what aspects of continuous testing make sense, and why it is important, what is the role that it plays in the overall context of DevOps, and what are some of the best practices of continuous testing. And then we looked at a case study in an enterprise product development environment. What happened before implementing continuous testing, and what happened after implementing continuous testing in the DevOps pipeline. What are some of the benefits and some of the do's and don'ts, and some of the return on investment cases? What are some of the best practices, and how the team has done? And we've looked at sample test reports and so on and so forth. With that, we come to the end of this session. This is the Lessons from the Field series. This session is about testing in DevOps, continuous testing in DevOps, some of the strategies, tools, and the best practices. This session is presented at the World Conference Next Generation Testing in Bengaluru in July 2019. Thank you very much for your time. You can let us know your feedback on my Twitter handle, bnandury. That is BNANDURY. All the best.